Today, our topic is applying what you have learned about turning points to solve problems. So, till now, we have studied all the topics, but now we discuss some problems involving all previous topics. Okay, whenever you see a question asking about the maximum value or minimum value of a quantity, you are likely to use differentiation. At some points, most questions will involve creating a formula, for example, for vacuum, for area, and then calculate the maximum value of it, right? So in this case, we basically use the previous knowledge to solve different problems. Okay, so this is your example 19. In this example, a large tank shown is to be made from 54 meters square of the sheet metal. It has no top. Show that the volume of the tank is given by V is equals to 18x minus 2 over 3x cube. So we have to show that its volume is this one. Okay, this is your part A. Part B is that calculate the values of x that will gives the largest volume possible and calculate what is the volume is. So it means that we have to find the maximum value of x, and after finding the maximum value of x, we have to put this maximum value into the volume to get the maximum volume, right? And the third part is justify that the value of v you have found is a maximum, so we have to also justify it. And this is your given figure, that is its length is y, its width is x, and its height is also x. Okay, so first of all, you can see that we have the formula for the volume of uh, this figure, that is like a tank. Okay, so v is equals to length multiplied by width multiplied by height. So length is y, width is x, and height is also x. So that can be written as v is equals to x multiplied by x multiplied by y. So we simplify it like v is equals to x square y. Okay, after that, the surface area of this tank can be found by the finding the surface area of this side and the surface area of this side. The area of this side is x square, the area of this side is also x square, because its length, its width and its height is x. So it means that the sides, the right side and the left side has the area, that is 2x square. And now the area of the three sides, because we have not the fourth side, it has no top. It means that next next area is, this is length and this is height. So it means that length is y and height is x, and we have three sides, so area will be 3xy. Okay, so the total surface area is the sum of these two areas. After that, the second step is find the way to remove a constant. In this case, y, you can write the surface area formula in terms of y. So we can write the surface area formula in terms of y, as it is given that the area is 54 centimeters square. So we just put surface area is equals to 54, and you have an equation, that is 54 is as it is, this 2x square goes on the right side, it will becomes 54 minus 2x square is equals to 3xy. If we are finding the value of y, so it will becomes 54 minus 2x square over 3x. So this is the value of y. After that, we have the volume of the tank formula, that is x square y. We just put the value of y into this formula. That will becomes v is equals to x square as it is, and y has the value that is 54 minus 2x square over 3x. So it will becomes this x square multiply into this term, it will becomes 54 x square minus 2x raised to the power 4. Do you have any problem till this step?
No.
Okay, good. Next one is, you can see that uh, we simplify it, 54 x square over 3x, so x can be cancelled out by x square, so it will becomes 18x, and 2 over 3 x cancel out by this x raised to the power 4, it will becomes 2 over 3 x cube, right? After that, this is your part A solved, as your volume is 18x minus 2 over 3x cube. After that, we are now doing the part B. For finding part B, dv by dx is basically equals to the derivative of this volume with respect to x. So derivative of 18x will be 18, and the derivative of 2 over 3x cube, 2 over 3 is constant, so it will be as it is. So 3x cube has the derivative 3x square, right? This 3 is cancelled out by this 3, so its answer will be 2x square. Now for finding the critical points, we have to put the derivative of this equation equals to 0, so it will becomes 18 minus 2x square is equals to 0. After that, this 2x goes on the right side, and it will becomes plus 2x square is equals to 18, and when we simplify it, this x square will be equals to 9, because this 2 divided by 18, and x will be equals, when we take the square root on both sides, the square root of 9 will be plus minus 3. So these are the two values of x. Now these are the values of x. We just put these values into the formula of volume. So what is the formula of volume? That is v is equals to 18x minus 2 over 3x cube. So it will becomes 18 multiplied by 3 minus 2 over 3 into 3 raised to the power 3. So your answer will be 36 m square, right? This is your maximum value of the, which one? Maximum value of volume. Okay, because there is a maximum at x is equals to positive 3. Since the length cannot be negative, so we use just x is equals to positive 3. Okay, now part C is that we have to justify that v we have found is a maximum value, so we also take the double derivative. So double derivative of this one, 18 has the derivative 0, and minus 2x square has the derivative, that is minus 4x, and again we put the value of x into this term, so it will becomes can you hear me?
Yes.
Okay, so we can just put the value of x into this equation, so it will becomes minus 12. So minus 12 is the negative, so it means that the double derivative is negative now. So when the double derivative is negative, it means that we are dealing with the maximum value. So this is negative, so v is equals to 36 is the maximum value of the volume of this tank. Do you understand this example or not?
Yes.
This is quite easy example. Can you solve it? Can you solve it now by yourself?